Theoretical recap. A routing table is a data structure stored in the kernel of an operating system that determines how network packets are forwarded from one network interface to another. Every Linux machine, whether a workstation, server, or virtual machine, maintains its own routing table, which the kernel consults for every outgoing packet. Each entry in the table typically contains a destination network, expressed in CIDR notation, for example, 192.168.1.0 out of 24, a gateway, the next hop IP address, a network interface, for example, eth0, low, and a metric, a cost value used to prefer one route over another when multiple routes exist. A common mental model. Think of the routing table as a postal sorting guide. When a packet arrives at the kernel, it looks up the most specific matching destination, longest prefix match. If no specific route matches, it falls back to the default route, 0.0.0.0 out of 0, which points to the default gateway, typically your router. Common mistakes beginners make: confusing the gateway address with the destination network, misreading the CIDR prefix length, especially /24 versus /26, which you practiced in the subnetting module, and forgetting that the loopback interface, 127.0.0.1 out of 8, is always present and routes local traffic internally without leaving the machine. Mini example: a route entry like 192.168.10.0 out of 24 via 0.0.0.0 dev-eth0 means packets destined for any address in the 192.168.10.0 to 192.168.10.255 range are sent directly out of interface eth0 without going through a gateway, direct/local route. Contrast this with 0.0.0.0 out of 0 via 192.168.10.1 dev-eth0, which is the default route sending all unmatched traffic to the gateway 192.168.10.1. Workshop brief. This workshop is the practical continuation of the simplified routing and routing tables lesson and consolidates your understanding of subnetting, CIDR notation, /24, /26 ranges, as well as your ability to read and interpret low-level network information, skills you will rely on constantly during reconnaissance phases of a PenTest or when auditing a network infrastructure. The goal is to make the routing table tangible, not just a theoretical concept, but a live, readable artifact you can interrogate, interpret, and analyze on a real Linux machine. Your working environment is a Linux virtual machine. Any distribution: Ubuntu, Debian, Kali Linux, or equivalent. If you do not already have one, you may use a local VM, VirtualBox, VMware, a cloud instance, AWS EC2 free tier, Google Cloud Shell, or a pre-configured lab environment such as TryHackMe or HackTheBox if available through your course platform. The machine must have at least one active network interface connected to a local network or NAT. Having a second interface, bridged or host only, is a bonus that will enrich your analysis. Step 1. Display the routing table using multiple tools. Your first task is to display the routing table of your Linux VM using at least 3 different commands. You are expected to use IP root show, the modern iproot2 approach, root, and the legacy NetTools approach, and netstatrn. Do not simply run them and move on. For each command, carefully note the differences in output format, the columns present, and how each tool represents the same underlying data. Take screenshots or copy the raw terminal output. You will need it for your submission. Pay attention to how the default route is represented in each tool, whether the gateway column uses 0.0.0.0.0 or an asterisk to indicate a direct route, and how the metric column is displayed. Step 2. Decode each route entry manually. For each route entry visible in your routing table, write a plain English explanation of what it means. You must explain the destination network in CIDR notation and the corresponding address range, apply your subnetting knowledge from the previous exercises, the role of the gateway or the absence of one, the interface used, and what type of traffic this route handles, local loopback, LAN direct, internet bound via default gateway, etc. If your VM has a loopback interface, low, and a main interface, eth0, ins33, in0s3, or similar, make sure you explain both. If you have more interfaces, explain all of them. This is the core analytical work of the workshop. Step 3. Add and verify a static route. Using the IP route add command, add a temporary static route to a fictitious destination network of your choice, for example, 10.50.0.0 out of 16, pointing to the gateway IP of your current default route. Verify the route was added correctly by running IP root show again. Then delete the root using IP root del and confirm it is gone. Document each command you ran and the output you observed. Reflect on this question in your submission. In what real-world scenario would a security professional or a DevSecOps engineer need to add a static root manually on a Linux machine? Step 4. Cross-reference with Wireshark. Optional but strongly recommended. Capture traffic on your main network interface using Wireshark or TP-dump while pinging a remote address, for example, 8.8.8.8. Observe which interface the ICMP packets leave from and confirm it matches what your routing table predicted. If you have time, apply a BPF filter, as practiced in your Wireshark sessions, to isolate ICMP traffic. This step ties together your Wireshark skills with your routing table analysis and gives you a concrete view of how the kernel's routing decision manifests as actual packets on the wire. Submission and deliverable. You have 2 hours to complete this workshop. You must submit your solution before the deadline expires. Your submission must include 1. The raw output of the 3 routing table commands from Step 1, 2. Your manual plain English decode of each root entry from Step 2, 3. The commands and outputs from Step 3 along with your written reflection, and 4. Optionally, a screenshot or packet capture excerpt from Step 4 with a short comment. Your submission can be a single structured document, PDF, Markdown, or plain text. There is no single correct answer. The quality of your analysis and the accuracy of your interpretation are what matter. You are fully authorized to consult all previous theoretical lessons from this chapter, your subnetting notes, and any internet resources, man pages, official Linux documentation, forums. You may work alone or ask for help. However, the written interpretation and reflection must be your own.